So yes, my name is Jesse. Thank you for the opportunity to be here today. I'm going to speak about my project this past cohort that was on electrical outages in the United States. A little bit about myself. I'm a proud dad of two teenagers. I'm an electrical engineer. I've been there for about 10 years at the local utility. And all of my favorite work projects are ones where I get to do some coding because I've been coding my whole life. And I am a graduate of a couple of the CodeU pathways in C# development and the cohort that just ended in Python. So my project was really shaped around the central question of whether wealth insulates consumers in the United States from electrical outages. CodeU kind of set out some parameters for the course that involve, identifying data sources and tools and timelines and deliverables. One of which was creating a relational SQL database, and the design of and implementation of that was really what the main and the most fun aspect of working on the project for me, and ultimately ended in generating plots and drawing conclusions from the analysis. So here are the three data sets that I pulled from, all from the US government, a database on all recorded outages as reported by utilities from the Department of Energy, also from the Bureau of Economic Analysis, statistics on GDP and personal income at the county level, as well as once it became clear that outages were almost entirely driven by weather events, I thought it'd be interesting to pull in some data from FEMA, so I did that as well. You see here is the crow's foot diagram that reflects the database design, and you'll see it kind of mirrors the data sources with three different tables there, and one extra that is just the counties, just to hold the names of the counties in the state and their identifier in those tables. I'll say one of the mentors from my class demonstrated a relatively new Python IDE that he uses every day at his workplace, and it's written in Python, unlike Jupyter notebooks. This is an alternative to that one. You use it pretty similarly. You start like any Python project, creating a virtual environment and activating that environment and loading your prerequisites into it. But then you can use this Marimo edit command, and it will actually launch the interface in your browser like this. It looks very similar to VS Code with your file explorer on the left and cells on the right that you can populate with your Python code or Markdown or SQL queries. So moving on to the data, when I looked at it, it became clear that there was a number of ways to count outages, as the number of events, the duration of the events, or the customer hours, like the duration times the number of customers impacted. And so this required, in order to put these all on the same scale, to meaningfully compare them, I had to engage in some normalization. So here's a couple of SQL queries that do that. And this is applied to both the state and the county level to generate those data sets. Putting those queries together, and it has helped generate statistics. Used window functions to generate statistics that represent, for every state and county, what percent of outages, for example, out of the total were there. And so I could generate a data frame such as this one that shows those percentages, and then put it back as a temporary SQL table from which to query and then create a graph such as this one, where you see those three different ways of measuring are all on that same Y scale. And if it's a percent, it still makes sense to compare them to each other. So here's a visualization that reflects the conclusions from my project, and you can see wealth doesn't insulate folks from electrical outages. It correlates to them. And in retrospect, I think that makes sense. Where there is more economic activity, there's bound to be more outages and more exposure to more electrical connections, more exposure to outage events. So the conclusions from my project, along with that point, I thought another item that was really interesting was to see how perspective really frames the data. Even looking at this chart, the trend is kind of obvious from here, but it took some zooming in and playing with the parameters to really see that trend. And also where I work, a lot of folks are using R, and I had never gotten to use Python before, but I understood that R and Python were similar. My experience after the cohort is that Python is way better and way more fun. in my opinion. And that's all I have. I appreciate everybody's time today. And here's where you can get in touch with me if you'd like.
Thanks so much, Jesse. That was an awesome presentation. Um, you mentioned a few things kind of early on about how it was maybe tricky to figure out like what to even track or how to determine what you were going to use as your parameters. Can you talk about what maybe the biggest challenge was in creating your analysis?
Sure. I think the biggest challenge was also the one that was the most fun for me was trying to turn, once I had mapped what I wanted my relational database to look like, trying to turn my raw data into that. So that was a function of just develop a process of just developing those functions. So it's kind of like solving a puzzle. That's what I enjoyed the most.
Yeah, that's really cool. And I love that your biggest challenge was also one of your biggest joys. That's awesome. I think that really set you up well for a career in tech. Thanks, Jesse.